The QuanTICo project was centred around a terahertz imaging system that we developed at Durham based on terahertz to optical conversion in an atomic vapour. And this means we can capture terahertz images much faster than any other scheme using conventional optical camera technology.
Many industries rely heavily on X-ray. However, there are limitations to X-ray. X-ray really looks at the structure of materials. Terahertz is able to be much more sensitive to the chemical nature of materials, and those chemical bonds tell you about how the material is constructed. The real advantage of this technology is that it sits in this gap between where optical imaging works and where electrical detection works. Now we have the ability to convert this terahertz radiation or millimeter wave radiation into green light.
The main excitement of this technique is really its raw speed, being able to demonstrate frame rates up to tens of kilohertz, which is thousands of times faster than other competitor technologies.
Historically, the images that have occupied this space have been slow and they've been very noisy.
Our high-speed imaging system means that terahertz imaging could be used where images need to be taken very rapidly, for instance at thousands of frames a second.
Things like shockwaves and explosions that occur on very short timescales, we are able to image. We can also take images of separate things in rapid succession. So for example, things on production lines or mail going through a scanner, for example.
I think this technology has the potential to revolutionise safety standards, for instance, in food production, in non-destructive testing. This has the potential to detect things that previously have been undetectable using traditional imaging methods. So one of the significant achievements of the QuanTICo project has been to miniaturise this complex optical setup on the bench into a device about the size of a shoebox.
This project could not have gone ahead without this partnership, without Ulta Technologies' expertise in packaging complex laser systems into extremely small form factor modules. These modular lasers were then taken by the Fraunhofer Centre for Applied Photonics and built into a larger system which is packaged into something about the size of a shoebox. This is a really good example of where we needed the collaboration of these partners to make something which is more than the sum of its parts. So one of the big advantages of this technology is that it uses a lot of off-the-shelf components. It has a more acceptable price point in a lot of industries. We really see that this technology has an opportunity to have an impact on industry, on society, and our understanding and advancement of imaging itself. If you're interested in learning more about this technology, please do get in touch with us.